All right, so we're now recording. I'm going to kind of open up the floor here to see if there are any questions about the midterm you just took, upcoming work that's either coming up this week or a group project, or moving forward to the last half of our semester, because we've just crossed the halfway point with the midterm. Anything out there? I'll tell you what, I think this class is probably my most squared away. I think I spent like the first 20 minutes on my class just prior to this talking about a midterm question. All right, so we're good. We're good to go. All right. So I'm trying to think if there's anything I wanted to touch upon before moving forward. I think, yeah, I don't think I have anything. If anything comes up, I'm sure I'll get sidebarred into it. All right, or sidetracked. So up until this point, we as you can, hopefully you're seeing a pattern build here with psychology and how we're getting a little bit more deeper into the mind versus the brain, right? Because prior to this, it's been a lot more of the brain as an organ and how the neurons fire and how we receive the senses. And then we talked about perception of those senses as more of a mental process. And then we got into learning, and then we got into learning and just kind of building in memory, getting into memory and how we store that information. Now, cognition is kind of the last piece to this puzzle on how we put all this stuff together organically. Okay, so still talking about the mind a little bit. Your book didn't get into too much as far as neuronal firing or neuronal processes with the neurons, but it does talk about the brain structure quite a bit because it's still relevant. But for the most part, we're still piecing how learning and memory and sensation goes together. But now we're looking at how does it come out? How do we observe these? And we understand that to be cognition and thinking, okay? So I'm gonna start off here with a definition. And the definition is really important. And like so many things in psychology, we have to have an output. We have to have an observable output, which I'll explain here with the definition in just a second. My screen ever, there we go. All right, so thinking. So the book definition that you got for thinking is any mental activity for organizing, understanding, and communicating. All right, so these first two, they're no-brainers, right? No pun intended. It's important for us to consider how we organize thoughts and understand concepts. And those are great, but similar to, I'm looking at my screen here and I've got probably about 80% of you that have your screens turned off, right? And I'm not giving you a hard time for that, but my point is, how can I know, like you're over there, you're on the other side absorbing this information? How do I know that you're able to organize and understand this information? Is there any way for me to ascertain that your level of understanding or organization here?
We have to communicate it to you.
Right, you got to communicate. So communication is really the only observable part of us telling if somebody is able to think, all right, which presents problems. So for example, if somebody is communicating in a way that the rest of the people don't understand, right? And we see that a lot. We saw that a lot with autism spectrum disorder, is there is communication, and there are ways for people with autism spectrum disorder to relay their thought and understanding process. But communicating is a little bit different for them, right? So organizing understanding, it happens. We don't know what level that is until they communicate. And that is apparent through verbal, nonverbal, and behaviors, because that's what we observe. That's how we communicate, okay, through those three means. All right, does that make sense? So let's talk about thinking as a mental process. And I'm also going to use probably this example next week as well. Mental process or mental imagery. So mental processing. So if you consider, I'll ask you a question. So I'm going to ask you to picture a tree. So who can tell me what a tree is?
The plant.
It's a plant. Okay.
It's very tall.
Okay. Tall.
Wood.
Green.
Wood. Green.
It has
Okay.
branches,
What's that?
branches on it.
Branches. Okay.
Gives off air, like oxygen.
Okay. Okay. So photosynthesis, right? Is that correct? Yeah, photosynthesis.
Leaf.
Leaves, has leaves. Okay. All right. Anything else?
Home.
What is it?
Home for animals.
Home for animals. Interesting. All right. So we have a pretty good idea. Many of you, home for animals, many of you have similar ideas, right? That it's a plant, it's tall, has branches, it's green, it's made of wood, it grows. Some of you got a little bit deeper into it, like it's a home for animals, okay? So we call these, within our thought process, concepts and prototypes. Prototypes. And within these concepts and prototypes, a concept, it's an idea that represents a category of objects, events, or activities. So I say the word tree, and for many of you, I would venture to say, and I'm probably pretty accurate in saying this, is that no two of you came up with the exact same image of a tree as the other person. Okay. That example there just kind of leads us to believe how our experiences and prior experiences and learning, different types of learning, vary for every one of us. So our concepts might be off, but within those concepts we have formal concept, and regardless of what example you gave me, you all fell into one of these two categories. Excuse me. And prototype are the three concepts and prototypes that we look at. All right, so formal concepts. Some of you understand that a tree is tall, right? You were giving me descriptions. You had formed an idea, a specific idea of what type of tree exists. So tall, for descriptives. We'll just put descriptives there. All right, and descriptives. So let's say, for example, I reversed that and I said, can somebody give me a single word for something that has branches, it's tall, it's made of wood, and it's green? Like, pretty much, I think everybody in this room, because you're all smart, right, would have told me tree. You would have said tree, okay? Because those are what we've adopted as formal concepts, okay? Now, somebody said something really cool in there, is that it's home for animals, right? So if I were to use that as an example, I would say, give me a one-word answer for something that's home to animals. I probably would have gotten a lot of options out there, right? But considering descriptive, so you're what we call fuzzy logic or fuzzy memory, and that's formed off of natural experience. I think we talked about this with memory, I believe, didn't we? Does anybody remember fuzzy logic or fuzzy memory? maybe not. Maybe I believe it was in your book for memory. But fuzzy logic is what occurs when we have experiences that tell us how the world works, right? Because we're all geniuses, right? We all know physics. We know that when we throw something, it lands on the ground. Sun comes from above, right? If we throw something far out from us, it won't go forever because gravity will take over, right? Without ever having to step into a classroom, we have a basic understanding of how physics works. Like psychology, many of you probably came to this class already understanding what somebody looks like when they're happy, what somebody looks like when they're defensive or angry, right? Or fearful. We know these things because we have these experiences of others around us, our interactions with the world around us. So that's all fuzzy logic is. It's just our understanding of psychology, of physics, of biology, just based on our experiences alone. All right. And it isn't until we get into classrooms that we either find out we were full of crap. I'd like to use an example here. I have a friend that thought that Alaska was an island. Okay. And her understanding of it, she really didn't. I'm trying to. She didn't understand that Alaska was connected to Canada. She's never been through Canada. She was an East Coaster from South Carolina, to be specific. And this, I'm not saying that people from South Carolina have poor education or understanding, but she never understood where Alaska was on a map. However, when you look at a map, where is Alaska? Like if you look at a map of the US.
It's like on the side,
Yeah,
like in its
like,
own little
Detached from the
area.
rest.
right. It's right above Hawaii, which would explain why it's a little colder than Hawaii. But yeah, if you look on a map, it's Alaska is right above Hawaii. So her concept of Alaska, it just made sense to her that Alaska was an island. She never had to look that up. So she was really engaging in fuzzy logic in that example. Okay. So prototypes. Now prototypes, we get a little bit more specific, right? We might, what are some types of trees out there?
Oak trees.
Oak
Pine.
trees,
Palm trees.
Pine.
palm trees,
Palm.
pine, maple, spruce, hemlock, right? We have a whole
Apple trees.
apple trees, right? We've got a lot of different types of trees out there. So our prototype, it's really an example of a concept that closely matches the characteristics. All right. So do concepts and prototypes, are we clear on those? All right. So also within thinking and thoughts, your book talks about problem solving. Okay. Now problem solving and decision making, it's a very expansive topic. Your book really covers a little bit of the information that's available out there. I could tell you that I've taken like 2 classes, college, like upper level classes on decision-making strategies. And there are a lot of theories out there, okay? So I'm only really gonna skim over the surface of this a little bit. So problem solving is when we use cognition to reach a goal by thinking or behaving a certain way. So problem solving is using cognition to reach a goal. Now, our goal, it really depends on what our behavior is, okay? So using, yeah, I mean, cognition is one thing. So for example, and I know nobody in this class would do this. How many of you, if I told you that our midterm and our final exams were basically 100% of your grade, how many of you would have taken that midterm without studying any material whatsoever? Is there anybody?
That happened to me last semester. I had a teacher who only gave us 2 grades the whole semester. It was the midterm and the final.
Oh, okay. I thought you were going to tell me that you took the midterm without having looked at any.
Oh, no, no.
Okay, so good. So explain to me, what was your motivation for studying, being that there was so much weight on that grade?
If I messed up on either one of the tests, then I would probably fail for the semester. So I was very motivated to study.
Okay. So your goal was, it was a high demand task because so much weight, you valued reaching that goal much more than if I told you, for example, for our midterm, it didn't even matter towards your final score. You would probably race through that. You wouldn't prepare for that, right? So our problem solving varies depending on the goal. So that's it's really important to understand, especially when we get into mental health disorders, okay? Because we are also in treatment of mental health disorders because we're also looking at goals in that area. And they become a little convoluted, especially when we start talking about addiction, because the goals for addiction, we sometimes get those wrong. We think, going back to ego, actually, we haven't covered that yet, but egocentrism. But we tend to think that as therapists and people that work with others, that maybe they have the same goal as we do, and that's a fallacy. That's faulty logic on our part, because they may not have the same goals. In fact, oftentimes they have very different goals. They have different triggers. They have different needs, and they're rewarded a lot differently. So it's important to understand goals when problem solving and making decisions. Okay, so high risk goals or high demand goals depends on how much risk we take. So anyway, that's I think I got a little sidetracked with that, but using cognition to reach a goal is really our definition of problem solving. So one way that we do problem solving, in your book, I think picked out a dozen. I'm only going to grab a handful of these to explain them because they're all kind of a variation of these. And again, like psychology, many things are just theoretical concept based on norms and averages. So really no hard, fast rules here. So trial and error. Trial and error is trying one solution after another. Now, does anybody have an example of trial and error? One solution after another until successful. Does anybody care to share something that they tried and tried until they were successful?
Learning how to ride my bike.
Okay, learning how to ride your bike. Why was that important, first of all? Why was that important for you to ride your bike?
Because I needed a way to get to school.
Okay, so out of necessity, right? Okay.
Yeah.
I would say mine was not necessarily to get to school, but more than to kind of fit in with my friends, because all my friends could ride bikes and I couldn't. So we all had different reasons to that, but yours was more out of necessity because you didn't want to walk, right? So that's a good
Right.
example. So trial and error. So what was trial and error for you? What did you?
I was falling off.
Okay.
Every time
Okay.
I tried to pedal off, I would fall.
Yeah. So you were really engaged in fine motor skills and balance, and you were fine tuning. So when you first get on that bike, what happened? Like within the first second of you getting on that bike and trying to shove off?
I guess I wasn't pedaling fast enough, so I'd pedal like 3 times, and then that's when the bike would start tipping over.
Okay. So you had to kind of balance, not only balance your weights on either side, but you had to know when to pedal faster, pedal slower, keep the handlebars right, all these things. It took a while, and you probably had some pretty nasty spills, right?
Yeah.
Yeah. That's a thank you. Is it Kyla, right?
Kyla, yeah.
All right, that's a great example of you trying to figure out, because there's really nothing that you can, there's no prescription you can give somebody for teaching them. Like if you were able to write down all the steps you need to do to learn a bike, do you think somebody's going to nail it first time, never having been on a bike?
Probably not.
Probably, I would say probably 100% of the time, not. I can't imagine any case where we could teach somebody to ride a bike having never been on a bike. Now, if they've been on like a unicycle and then we put them on a bike, they might have that balance. They might know how to do things a little bit differently. But not being on a bike, that's going to present some challenge. So trial and error is important in that until you were successful. And even when you were more successful, you probably had some spills, right? So that's a great example. So doing something one after another of succession of attempts until you're successful is the definition for trial and error. All right. And we kind of do that naturally with things. The other problem solving that we use is algorithms. Algorithms. I think I spelled that right. I believe that's right. Okay. So algorithms are specific steps. For solving problem. Okay. So let me give you an example. Using Kyla's example, if we gave somebody that didn't know how to ride a bike those instructions, they probably wouldn't be able to do it because they have to go through the trial and error. Everybody's bodies are different. Understanding that balance between the two of them takes time. So algorithms don't necessarily work in that situation. But so what are some examples for algorithms like where they would be successful, and what problem solving or decision making would algorithms be good?
For logical problems.
Logical problems, like, would you have a specific example? Excuse me.
Well, going through school is a logical problem. In order to finish, you have to go to classes, do your homework, and know that is taking steps. I would suppose.
Okay. So all right. So having like certain things like meeting your getting good grades in high school in order to get into college, so on and so forth, right? Kind of just
Right.
Okay.
Just that's a huge problem to solve.
Yeah, it is.
Takes
And
time.
and a lot.
How about playing chess? Is that
There you go. Good. Now there's a lot involved in chess. Do you play chess, Chris?
Yeah, I do.
I do too. In fact, I love using chess, especially with my younger clients, because you're activating in their mind, you're activating their creative and logical side together. And while you're talking about bringing up issues or topics that are keeping them from doing well in their lives. So I love chess. Thank you for bringing up that example. But that's a great example of algorithms, because in order to move a piece, right, you got to understand exactly how they move and what they do. So for example, a queen can go any direction, any number of any number of squares on the board. You have a knight that can go up 1 over 2 or up 2 over 1, left or right. So knowing those are algorithms. Now, getting to, let me ask you, Krasimir, what do you think about putting somebody in checkmate? Is that algorithms or trial and error?
Well, to get to the point to put him in a checkmate,
To win, yeah.
that'll be algorithms, because you take a lot of steps to get to that point.
Okay. And I know chess well enough to agree with you, because there are tons of books out there on almost, a million steps, like a million ways to look at a board and knowing exactly what to do next, right? So, okay, I would agree with you, only because I know that. But let me kind of bring this back a little bit here with algorithms. All right, so I hopefully you get that. So algorithms are a specific step. Like, for example, if I said there are specific steps to get you into Zoom today, all right, what are the steps to doing that? Well, first you got to turn on your computer. You may have to connect to the internet or connect to the Wi-Fi. You may have to log into, open up the program Zoom, log into Zoom, and then turn on or off your microphone. Many of you just turn off your video, right? So those are the steps to reach your goal. Now, if something happens along the way, like the power goes out, now you have to incorporate some different types of problem solving. So algorithms are for really just very automatic goals or automatic steps to get to a goal. All right. Does that make sense? Hopefully I didn't lose anybody on that. So the next one that I wanted to touch upon was heuristics. So heuristics is really just a guess. Guess. Based on prior experience. So for example, if you learn to tie your shoes, right? And that could be an example of an algorithm. We have an example at the end of what a shoe looks like when it's tied. Now, let me ask you if you can kind of picture this. If you were given a shoe and you kind of had a sense that it goes on your foot to protect your feet, but you never saw like somebody actually tie it and have a bow tie, how many of you think that you would have discovered automatically how to tie a bow like we know it today? I would venture to guess probably very few of you, because you've never seen the final product of a tie that's bowed like that, right? Nobody ever showed you how to do that. So you might engage in trial and error because you know this goes on your foot, and there's got to be a way that I can tie this so that it doesn't come loose. So you may get some funky looking knots, or you may just wrap around your entire foot and tie a double knot or something, because you know the strings do something, right? So you're probably engaging in trial and error. Now, heuristics. So let's say that you do know how to tie a knot with your shoe, and now all of a sudden you're in a boat and you're asked to shore up the boat on the dock, and you use a bow tie to do that. Any boaters out there? What happens if you use like a slip knot to tie up your boat? What happens to your boat?
It'll come undone.
It goes away, right? It's going to probably slip out and float off to sea or float off into the lake, and you're going to have a hard time getting it back. So heuristics is just that, based on prior experience and availability of your resources, you're able to come up with a strategy to solving your problems. And again, that's kind of like a mix between algorithms and trial and error, but it's an educated guess. Availability of resources. Okay. All right. So those are the three decision makings that problem solving decision making tools that I like to use out of your book. The rest of them are kind of variations of those. All right. So let me talk about some problems with problems, or problem solving. Problems with problem solving. Now, the reason why this is important, problem solving, 2 words. The reason why this is important, and again, when we look at psychological disorders and treatment, we want to know what somebody's ability is to cope with their life's problems. For example, if somebody constantly engages in trial and error and they don't have the trust to really believe that that somebody might have an answer for them and can help them, do you think that they're going to have a harder time being successful with the therapeutic process? Absolutely, they will be. Okay, so it's important for us to understand how their problem solving occurs, and where their mental abilities are. So one of the problems that we can see with problem solving is confirmation bias. Now, let me ask you, maybe somebody has anybody had like a feeling that something bad was going to happen and then it did?
I did.
All right. Do you care to share what your experience was with that?
So like when I got in my car one morning, I felt like I was going to break down on the side of the road.
Hmm.
Like there was nothing wrong with my car at the time, and then like suddenly I went down the road and my car completely, like my ball joint like completely broke on it. Like I had a feeling that something was going to go wrong with my car, and it ended up happening.
Okay. Okay. So you what happened is you had this feeling that something bad was going to happen that day. And then all of a sudden, something did happen. Your car broke down.
Yeah.
So what you were probably doing in that moment is you were susceptible. You were open to the experience that something bad is going to happen, and that's kind of similar to what happens with confirmation bias. So confirmation bias is searching searching for evidence that something. I'm just going to abbreviate something with ST. Something. Actually, search for evidence that I don't want to use something. Sorry, that confirms beliefs. But we're going to go one step further, and it's also ignoring evidence otherwise that refutes it. Now, what do I mean by that? And when some of you're going to be doing your research projects, you may have the tendency to do this exact same thing because we all have our beliefs and values, right? We may have ideas of how the world works. And when we see something that confirms that belief, we stick to it and we kind of raise flags and show all of our friends saying, hey, I'm right. I got this concept. I'm correct. Everybody else is wrong. And then you're presented with something that kind of refutes that belief. What do you think you're going to be more drawn to? If you're not a critical thinker, if you're not a very scientific mind, what do you think our tendency is to be drawn to? Something that confirms our beliefs or something that refutes it? What do you think?
Something that confirms it.
Something that confirms it, right? Because we as humans are two things. Anybody remember? I think it's been a while since I said this. We are, as humans, we are two things. What are we? I think you should put a Post-it note on your monitors because this might be a good bonus question for the final exam. By the way, we as humans are two things. What are they? Stomp, stomp.
I think one was curious.
Okay, a little off there. Jen, do you remember what I say? Have I brought it up with this class?
I don't think so.
Okay, I thought I did. I usually bring this up with all my classes. We are two things. We are lazy and we are proud. Okay.
You
Now,
have said it.
I have said
brought
that.
up.
You have
Yeah.
said it.
All right. Well, mark it down. It might show up as a bonus somewhere. All right. But we are lazy and we are proud. And I say lazy lovingly because we like routine. We like things. But this side of it, we are proud. Okay. So things that confirm our beliefs, it makes sense to us. It makes sense of our world, because if our world doesn't make sense, then we don't feel comfortable in it. And that's not a good feeling. So it's easier to feel right. And that's kind of what confirmation bias is. We just have this natural tendency to believe what we want to believe, to make sense of our world. So things that refute that trouble us. So thinking scientifically is being aware of confirmation bias and trying to overcome that by trying to come up with your own solutions. Okay. So the other one that I have is the other problem that I wanted to bring up to you with your book is mental set. Now, mental set is persistence in using past problem solving patterns. Now, what I would and I don't have a whole lot of time to really engage in this, but let's see if anybody gets this before I do. What I'd like y'all to do is take out a sheet of paper and a pen or a pencil or whatever. All right. And draw this design. Okay, I'll just give you a minute to do that. Okay. Now, I'm going to give you 3 simple rules. All right. So the first thing is you have to draw 4 lines. Don't do anything just yet. Second rule is can't lift pen. Third rule is can't touch more than 1 dot, or dot more than once. I'm sorry, dot more than once. All right, so your task is to draw, based on these rules, draw 4 lines and connect all of these dots without lifting your pen, and can't touch one dot more than once. Okay, I'll give you just a minute. See if anybody is able to get this. And if you got it, just speak up and let me know.
I think I got it.
Every dot.
All right, CJ, and who else?
No, we gotta touch every dot.
Yeah, you got to touch every dot has to be have a line touching through it, and it's got to be 4. You can't lift your pen, and you can't have it more than once. A dot touched more than once. Oh, okay. So every dot, CJ, you got to have every dot. So you're missing
Really?
about 1, 2. You're missing like 4 of the dots were not touched in your line. All right. Does anybody have it? Maybe another minute or 2. Some of you engaging in trial and error.
Professor, I'm gonna have this right in like 2 minutes.
Well, unfortunately, we're running up on time, and I don't have time to do. I'll tell you what. How about we do this?
I think I might have got it.
All right, let's see what you got.
If you can see it.
All right, so 1, 2, 3, 4. You got 5 lines there, so close.
I want my diaper change. My diaper change.
All right, so I'll tell you what I'm going to do. I'm not going to answer this for you. I'm going to let you stew on this for a little bit and see who comes up with the right answer on Wednesday. Okay. So is that okay? Does anybody like need the answer right now, or do you want a challenge?
Challenge.
I want a challenge.
Okay. All right. So without cheating, I don't know if don't look this up in any way. See if you can get this. All right. And then we'll see who gets the right answer on Wednesday. All right. So just remind me if I forget. Yeah, we'll see what you get, but just remind me that we have it. All right. So the other part, the other problem with problem solving that I want to bring your attention to is functional fixedness. Now, functional fixedness is a little bit different. You know, when we look at mental set, we're looking at thinking outside the box. When we're looking at functional fixedness, excuse me, we're looking at thinking of only most typical ways typical ways to use something, to use the function of object. Typical way of using an object, typical ways of using an object. Okay. So for example, I'll give you an example of this. In fact, a true story. Just last night, while I was coughing and sneezing and having a rough day, it was the only day that I was able to get my wife's desk put together. She just finally received the desk that she's been waiting for about a month and a half. She teaches too, and she's been teaching from a card table. Bless her. But so I was under pressure to get this desk done last night. And within that time constraint, one of the tools that I found that I needed to tap dowel rods into the board was a hammer. Well, the hammer was a good deal away, and I didn't want to spend the time to get the right tool. Shame on me. So what I did, I had a screwdriver that I was using, and I was using the screwdriver to tap in the dowels every time. And there were probably around 20 of them, but it worked. But that's an example of functional fixedness, or overcoming functional fixedness, is using tools for something other than their intended purposes. And one of the examples I'm going to show you here, and it's not going to be the last time that you see this as an example, but so I'm not going to give you this as an assignment for next week or for Wednesday, but using the available tools or the available items here on the desk, how can you attach the candle to the wall above the desk so that when the candle burns, it does not drip wax on the desk? All right. This is called the candle box problem. When we get into motivation, I got a cool little video to show you about motivation and incentivizing people to do this job quicker. But using creativity. So has anybody seen this before? Does anybody have the answer to how to do this?
I haven't seen this, but I think I know the answer.
Okay, go ahead, Stephanie.
I've seen this before.
All right, let's see if Stephanie has this.
You take all the matches out of the box, put the
Okay.
candle in the box, and then attach the box to the wall.
Very good. Absolutely. Using the candle or using the box of matches, right? Like using something that wasn't intended for that to complete your task, to reach your goal. So absolutely. And for many of you that have seen that, great. We're going to show this video. Like I said, it's Dan Pink, which we'll show here in about 2 weeks. Great video on how to incentivize this and how people that were incentivized to do this more actually completed this task in a slower time than people that were less incentivized. So anyway, really cool stuff on this. But that's essentially all I have as far as problems and problem solving and cognition. I know, like I said, I apologize. I know your book went into a lot more. I do want to cover a little bit more, as well as how intelligence plays into this on Wednesday, and whatever time we have left on Friday, finish up our talks on cognition and intelligence. Any questions or comments before we depart today? Anybody have anything to add? Okay, and again, I apologize. I probably sound very squawky and not great today. It's not my best radio voice, but hopefully Wednesday I'll be a little bit better. I'll do some chloroseptic sprays or something like that, make it a little more pleasant for you. It's hurting my ears just hearing me talk. But anyway, that if you have nothing else for me, have a great rest of your day. I will see you on Wednesday. If anybody needs anything, I'll be around for just